Today I'm going to do an unboxing and review of the new Sindoh 3DWOX1 3D printer and do a little compare and contrast with the previous models, the DP200 and the DP201. But first, an overview and some specifications. The 3DWOX1 is a user-friendly and reasonably affordable fused filament fabrication 3D printer that combines a sporty, polished design with competitive specs and rock-solid build quality. But the 3DWOX1 takes a big leap for Sindoh, now allowing open-source filaments to be used along with the proprietary chipped filaments of the past. The new 3DWOX1 has a lot in common with its sister models, the DP200 on the right, shown here, and the DP201 on the left, but it improves on or solves several of the issues with the older models. You see, the new 3DWOX1 combines the best of both previous models, sporting the heated aluminum bed of the DP200 and the flexible build plate of the DP201, allowing great quality prints with ease of removal. The flat magnetic surface of the new 3DWOX1's build plate solves the problem I had with Y-axis play on the original DP200's aluminum bed, as well as solving the bed adhesion problem I had with the sister model DP201's build plate. And the new flexible heated bed plate not only affords great quality prints, but also provides the ability to flex and bend the plate to ease print removal with less use of the dangerous scrapers, knives, and other tools. I reported both of these issues to Sindoh on their previous models, and it's great to see a manufacturer that listens to its users and responds accordingly. But wait, that's not all. I noticed right away that the 3DWOX1 is way quieter during operation than previous models. Actually, all I regularly hear is the fan noise. It is a significant improvement. I could stop here and we'd have a superb machine, iterated over several models to result, in my opinion, to be the best feature-rich and performing 3D printer for this price range. But the 3DWOX1 has one last trick up its sleeve. It now supports open-source filaments. Yes! Sindoh listened to us users yet again and have allowed any third-party filaments to be used with this machine. On paper, it supports PLA, ABS, PETG, ASA, and PA. On-screen guidance assists you in loading and unloading open-source filaments. The 3DWOX1 measures in at just under 18 inches cubed and weighs a reasonable 33 pounds. It uses both proprietary chipped filament, currently available in 9 colors, as well as open-source filaments on spools less than 67 millimeters wide and less than 213 millimeters in diameter. The proprietary filament affords the ability to control the quality of the materials used and allows auto setting of machine-specific parameters to allow the best prints possible. It also provides the neat filament auto load-unload feature, which I've grown to love. But I think I'm really going to love the ability to use different colors and styles of open-source filaments. The printer can be attached to your computer via USB cable and wired or wireless networking. Very capable slicing and printer management software is included, but third-party slicers can be successfully adapted into the workflow easily. Here are some detailed machine specifications. Here's a chart of what I believe to be the most important differences between the 3 sister models which are currently on the market. The Sindoh 3DWOX1 3D printer, filaments, and replacement parts can be purchased from and shipped directly from Amazon, which is great for Amazon Prime users. I really enjoyed using the previous DP200 model for my designs and prints over the last several years, and I think I'm really going to love the new 3DWOX1 and its enhancements and improvements over its older sisters. In my opinion, the 3DWOX1 is to date the easiest and best quality turnkey 3D printing solution for the masses. Here we have our 3DWOX1, manufactured April 18. Nice handles for transporting around. You pop out these 4 clips at the bottom here, and the lid comes off very easily for unpacking. We're provided what looks like a full cartridge of white PLA filament. A standard IEC power cord, looks about 6 feet. Also provided a USB cable, which is a nice touch. A nozzle cleaning tool, which you would use to push down in the top of the nozzle to evacuate any filament. A scraper, nice touch. This is a spring nozzle cleaning tool and a tube for cleaning the nozzle, and a USB drive which has your software on it. Also included is a quick setup instruction manual. Let's dive in and unpack this baby. Like any printer, remove all the orange tape, inside and out. The bed is well secured for transportation with a giant tie wrap. Use wire cutters or a heavy pair of scissors to cut it, and carefully remove the packing from the bed. And now a quick overview. This is the 3DWOX1, very similar to color and style to the previous DP201. Has the transparent smoked doors, which are lighter than the original DP200, which is nice. Cartridge goes in here, or your open source filament spools. Your 5-inch display, your power button, and your heated metal flexible bed. Just grab it in the front, pull it out, flex off your parts. Real nice concept. Combines the both of the DP200 and the DP201. When you're done, slide it the whole way in, drop it down. That's it, you're in. Magnetic. On the back, there's a power connector, Ethernet network, and USB, and a replaceable HEPA filter. Just some vents on the side. The measurements are roughly 16.5 inches, 14.5 inches in the front, a little over 17 inches in the back, and about 17.5 deep. The original DP200 had this non-flexible heated aluminum bed. You push these clips down, popped out this rigid bed. And I always had some issues with the play and the Y-axis on this because of those clips, but it did some really nice prints because of the solid aluminum bed. Now the DP201 did PLA only, but it had the flexible rubber bed. And this was great for removing your prints, but I had issues with this, with warping and not sticking to the bed because it wasn't heated and it wasn't completely flat. So this is where I think the 3DWOX1 is going to excel. The bed has the properties of both the DP201 with the magnetic flexible bed, but also the heated aluminum metal flat bed of the DP200. Let's power it up. I won't make you sit through this, but it seems to take about a minute to boot up. On the first boot, it wants us to finish leveling the bed, so we'll do that. If there's a printed object on the bed, please remove it and press OK. What's happening now is the bed is lifting to the home position, and I can hear right away that it's much quieter than the DP200 or DP201. Right now it's actually checking the bed height or the bed level. There's a little sensor on the bottom of the head, and slowly the bed is moving up and it's getting a reading. That's how quiet it is. It checks the back center and the front left and front right. And then it will ask us, based on those settings, to turn the knobs to adjust the front of the bed for leveling. Based on the readings, it asks us to turn the left knob 0.3 turns or 95 degrees in a counterclockwise direction. I'll make the adjustment as indicated. Hit the OK button, and it will go through the process again to check and get readings for the level. And after gyrating for a bit, it parks itself, and it says that our bed is level. We've been provided with one roll of white PLA chipped filament. Let's load that up in the cartridge slot. Easy as that. The display prompts, do we want to auto load filament? We say yes. I apologize for the dark video. The display is so bright that I had to turn down the iris on the camera so it would be clear. And it takes a little bit until the temperature is optimized and it can start feeding the filament through the tube and down into the extruder. But it is automatic on these Sindoh provided cartridges. Here we see it's optimizing temperature. Of course, at the bottom it knows that it's white PLA because of the chip. When the optimum temperature is reached, it will begin inserting the filament. The gearing will actually push the filament from the cartridge up through the tube you see in the upper left, where the black and the white tube are coming down into the extruder, and it's feeding the filament in and pushing some initial pieces, melting them down into the inside waste case. Let's tour the menus. The print button allows you to insert a job on a USB flash drive for printing. Cartridge, made for load, unloading, and unlocking on the Sindoh provided cartridges. Most of the goodies are in the settings menu. Let's go through some of these. The XYZ allows you to jog the head around in all three axes. We can move left 10 millimeters at a time, switch it to 100, go left 100 millimeters, go in the Y, then we'll move 100 in the Y direction, and so forth. We'll move on to the extruder option. This takes some time as it has to heat the nozzle up. Target temperature required. I just realized we can turn the internal lamp on so we can see a little bit better inside here. Go over to the lamp. On only when printing, always off, always on. There we go. Little light inside there now. Let's go back. Let's see if we can extrude a little filament through the nozzle. We'll go 10 millimeters. See if we can get it to squeeze out 10 millimeters. Doesn't take very long. Hit it again. Thought maybe something would be coming out under the nozzle there. Maybe I just can't see it. Yep, there we go. A little bit of white PLA filament. Be careful under there, that nozzle is hot. Bed leveling, we've been through that process already. Z offset, this allows you to move the nozzle and the bed closer together. It's at 0.25. We'll leave that as a default. You can adjust that later with a business card. Nozzle cleaning, takes 5 to 7 minutes, and it does a thorough cleaning, heats up real high, and pushes some filament through. The cleaning case is inside, and it's where excess filament goes, and you can clean that out every once in a while. Now, after the bed has moved down, we can reach in here and pull out our cleaning case, which has particles of filament that have been extruded through the head and wiped off. Clean that every once in a while when it tells you. Now, I just noticed this appears to use the same nozzle printhead as the DP200, with the fan on the front and the fan on the side, and this connection up here. This looks very similar, so I believe it's the same head as the DP200. Again, this is noticeably quieter in the Z-axis movement than the previous models. Continuing our menu tour, let's go into networking. Of course, you can do wired or wireless, which is nice. We'll go on to the next page of options. We did look at our lamp before. The lamp is right up under here. You can have only on when it's printing, on all the time, or off all the time. It does make a difference. Bed lowering, obvious. Power saving mode, you can set when you want it to go to sleep. The beep sounds the menu makes, high, low, medium. Nozzle setting, you only use this after you change your nozzle. There's a number written on the bottom of the nozzle from the factory, and you put that in there to match it up. Different languages for our display. Oh, I can't read that. You can have it send you email notifications on your jobs. I've never set that up. Units, of course, you can do Celsius, Fahrenheit, meters, feet, imperial units, metric. Our time looks correct. Not sure where I got that from. Maybe it was set because I haven't hooked it up to the network yet. Set your time zone. And there's actually a web browser built in here, which I've never used. I'm not sure. Of course, I'm not on the network yet, but I don't have a lot of use for that. Security, I would assume you could put a pin or something on here to keep people out of this thing, like at a school. Software updates you can do right from here once it's hooked to the network. And open materials for your open source, you have to turn that on. It changes some of your menu options. We'll get into that later. Now, the first thing you should do with your new printer is do a small test print. They were kind enough to provide some test prints in the menu. Now, the display says this print will take about 13 minutes to complete. And because it's so small, most of it will be obscured by the head here as it's running, but it'll give you some sense for what the printer sounds like as it's operating, the speed of the first layer versus other layers of the print, and just give you some idea of how this thing operates without investing too much material or time. And I'm sure there's a few DP200 and DP201 owners out there who are listening right now and saying that doesn't sound right. But I believe that's how quiet this new machine is. You don't hear that servo whine that you heard before. Most of the time, I just hear the fan noise. Now, yes, as it moves up the layers, it does increase in speed, and it is a little noisier. But remember, I do have the lid up here to take video. Once the bed has cooled down to about 50 Celsius, we just grab here, remove our magnetic bed, flex it a little bit. Let's see if we can get our part off. Yep, popped right off. Awesome. Put our bed back. And there we go. Now I'll just do a real quick overview of the software they provide. Here I'm adding my printer. It found it on the network. I use the Ethernet on mine. It shows over here 3DWOX1 white PLA. I can go into settings. When you're in easy mode, you can just say fast, normal, slow speed versus quality. I usually run in the advanced mode though. It gives me a lot more options I can choose. Just change it like that to advanced mode. Now when you go to settings, you have these tabs at the top here, setting your layer height, your nozzle temperatures, and the Sindoh PLA and ABS have presets in here. So this is the easiest way to get started without causing yourself any trouble. Looking in the bed adhesion tab, they recommend a raft. I like to print things without them, but your mileage may vary. Quality of your infill, your wall thicknesses, top and bottom layer thicknesses, retraction combing. Speed, your print speed, 40 is their default, 10 for the first layer. Here's your cooling settings and your retraction. And some advanced options over here. But it's very capable software for slicing and printing. Here you can see your printing settings, which is nice across the network. Look at your cartridge information. Now I'm just going to show some of my first test prints that came off this machine. I really pushed it to the limit. I really prefer to use Simplify 3D for my slicer, and I was able to do that on here. I had to set up a profile that was similar to that for the 3DWOX. So the first jobs came off here. This is the very first one that I printed. I went in, it was an old job that I had designed in Fusion. I sliced it in Simplify 3D, and then I used the Sindoh 3DWOX desktop software to load the G-code and send it by network over to the printer to print. And while it was pretty nice, I really felt that the first layer was not smashed down far enough, but I hadn't adjusted anything, so I've since decreased the gap between the extruder and the bed and played around with a couple settings to get a more squishy first layer. Here's this first job midstream. Let's remove this first job from the bed. Now you're going to see a lot of this model throughout my channel. This is an Arduino Uno case. It has these nice screw bosses here and these little pins sticking up, and I print without a raft. It's my version of the 20mm test cube. I like to see if it'll work, and I have other videos on my channel where I did this with some ABS, some PETG, Simplify 3D, so check those out and see what my settings were like and what I got as a result. This job I had a decent amount of trouble with printing on the DP201 because it would warp up on the edges, and if I used the Sindoh software, these little pegs would break off. Now again, this was sliced in Simplify 3D and sent over the network, but I think the quality came out really nice for a first print. It's flat, there's no warping, it's solid, so I can tweak the Z-gap a little bit here to fix that first layer, but for no raft, came out pretty nice. Here's a set of print-in-place tracks. Again, I will print this with no tweaking. It's the second print I've done on the machine, and we'll just see how it comes out. If it comes apart, let's give her a shot. When that slides out there, it always reminds me of something like a Star Trek replicator or something. It's pretty cool. Anyway, let's see what we have. Pops right off. Now, they're print in place. They're hinged. Will they break apart? This is the white PLA provided by Sindoh. Oh. Yeah, I mean, a little stiff, but no, they came out nice. This is a small enclosure that I made to put some weather station components in for one of the projects I did. I always had some issues with this because of the sharp corners and the flatness on the bed. It would warp up and pull off, so let's give this one a shot. It also has those screw bosses, those real high screw bosses. Here we are, a few layers in. It's looking pretty good, nice and flat, adhering well to the bed. Now here we are a little further on in this project. I will admit I didn't tweak any of the settings in the slicer, so there's that gap in the concentric rings there on the screw bosses. Now this one I used the Sindoh slicer, and that's part of the reason those little gaps in there why I like to use Simplify 3D. You can do that single extrusion fill and you won't get that problem. But again, I didn't do any real tweaking here. This is just printing one off. Now let's remove this project from the bed. I can see something went on here with this one screw boss. There's a bunch of particulate hanging off of it there. Again, I used the 3DWOX software on this one. This is the kind of thing that happens when I do that. That's why I like to use Simplify 3D. There's a little ringing over here on this edge, but not bad for what second print or so I printed off of here. Nice and square. The gaps in here, these little holes with no supports or anything, they came out real nice. Decent finish. Look at these holes on the bottom. Real nice. Now inside here, I don't know what went on this one screw boss. Something clearly got out of whack and caught on something, but luckily the strength is there. I can use it. It recovered and it kept going. Just a little flash on there. And over here too, but again, no supports. So what do you expect? You're just coming up there on an angle. Perfectly usable part. Real happy with it. Imagine what happens when I tweak it and get the parameters set in. Now, as far as open source filament usage, I'll just touch on this briefly here. I'm probably going to do an entire video on that. It warrants it. You basically have to go into the menu system here and say, I want to turn on open source filaments. And then it gives you a bunch of prompts and warnings because you're not using the Sindoh chipped filament on how to load it up. And there are some little tricks and tweaks I learned along the way, and even a modification I made to fit some larger spools. So I'll do that in another video. But the general concept is you get the settings right, you take your third-party filament spool and put it in where the cartridge was, and then you tell the display, on the display you say to start loading, and it starts running the gears, and then you insert your filament into this little slot over top of this peg here, and it'll start pulling it in and it'll load it up. Here's some Hatchbox filament in orange, 1.75 millimeter diameter. I was able to load that up. Again, I had to make a modification to handle the larger spool. I'll do that in another video. And also since then I've tweaked the Z offset so that these gaps weren't in the first layer. But after it prints, it looks perfectly fine. And I did nothing. I printed this, I sliced it from Simplify 3D. I used the same settings as any of the Sindoh filament for as far as temperature and speed and everything. I didn't tweak anything. I just let it go as default for now, and it worked beautifully. Here I was printing my Arduino enclosure using multiple open source filaments and just wanted to look at the tolerances on the pegs and the screw bosses to see how consistent they were. So the orange was Hatchbox. The coffee color there was AMZ 3D filament, open source. Of course, the white was the Sindoh provided chipped PLA. All three of these are PLA filament. Look at the nice finish on here. I'm very, very happy with it, considering I did no tweaking for any of the materials. Just went ahead and said print. See if these go together. That's a nice fit. Yeah. Matter of fact, it's a little tight. It's going to be hard to get apart. But that looks really nice. I'm real satisfied with that. Look at this first layer here for the MakerBot robot. This is with open source filament. And again, it could be squished down a little more. This is before I tweaked it on the Z offset. But I mean, that is some amazing accuracy there and a pretty nice first layer, given that I didn't tweak anything or fix anything up. And I'll show you how he works. He's a print in place robot and it worked perfectly. And real quick, I'll just show you this dude. He's a MakerBot, I believe a MakerBot robot, print in place, fully articulated. I mean, his hands, his knees, his head, everything. I've had to print him many times in the past. This was one off, no adjustments to the printer, probably like my 5th print, open source filament, using Simplify 3D as a slicer. I mean, I just put through everything at it. And, you know, you got a little flash under here, but other than that, I won't make you sit through me breaking him all apart, but suffice it to say, except for one of his little joints in his knee, everything just came apart and he fully articulates after I snap him apart. I didn't even cut anything. I just used my hands like this to loosen everything up and break it apart. And here's the little demo robot guy after I loosened up some of his joints. Again, like I said, this one knee just wasn't working real well, but he's perfectly serviceable. Every other joint worked. That one there just, I should have just been more cautious with it and used the knife or something to cut it open, but I was just anxious. So there you go, little maker robot with a busted knee, a bum knee as they call it. But he's pretty cute. It worked out pretty well. Stay, little man. And this is the Sindoh ABS filament in their cartridge. I did spend a decent amount of time trying to get a profile that would work for it through Simplify 3D with the right settings. So actually this is coming out pretty nice for as far as ABS. I really don't print a lot of ABS though, but I just wanted to see if it would do it. This is the same ABS. This is one of my photo battery holders that I mount on the wall. There is some warping in this front left corner, but it's pretty many layers of solid ABS on the bottom there. No supports were used, so I can just clean out those little holes there with my scraper. Again, what's nice is it just pops right off. Not the best print, but remember, no glues, no tape, no hairspray. Right on the bed here, and it popped right off, and I don't print a lot of ABS. Here's a 3D benchy using the Hatchbox Orange PLA in the open source mode. Now this is Pet G. I did head down that path. It took quite a bit of time to get a profile in Simplify 3D that worked for it, adjusting the temperatures and the bed temperature and the offsets and just all kind of stuff. So I will make those profiles available at some point for Simplify 3D, but I think I'm going to do a whole video later on what I did to set up and get this Pet G working. And this is Pet G also. It's the eSun brand. This is the first layer. And a close-up of the completed Pet G project here. Well, I promise you this did not start out to be a 30-minute long video, but if you hung around until now, congratulations and thanks. And if you think about it, a 3D printer with supplies is an expensive purchase, so why wouldn't you want to be completely informed as a consumer? Hopefully, I've hit on all the things you need to know to evaluate this printer, and I think you'll find that it not only competes very well against other options, but exceeds them in most respects. I can honestly say that the new 3DWOX1 is the best 3D printer I've used, and I would recommend it to anyone, beginner level to enthusiast, who wants a reliable, consistent, and easy to use 3D printer. And now with the ability to use open source filaments, the 3DWOX is even more desirable. I hope this has been helpful, and thank you for watching.